All right, so we're going to take a quick break from what we were doing and talk about ratios and proportions, because this is going to be a huge punchline for the rest of the unit. All right, so out of 248 students, 112 are seniors. What are the ratios of seniors to non-seniors? So we need seniors to non-seniors. Well, we already know seniors. Let me think. Seniors equals 112. Non-seniors, well, how many non-seniors are there? Well, 248 minus 112, which equals 136. All right. Now, so the ratio, which is just another word for fraction, is 112 over 136. All right, now we got to reduce this bad boy. What's the greatest common factor between 112 and 136? Truthfully, I'm not sure off the top of my head. I could have some educated guesses. But since these are both even, I know I can divide both by 2. All right, so what's 112 divided by 2? 56. What's 136 divided by 2? 68. 68. Timeout. Almost had a brain fart. All right. What's the greatest common factor between 56 and 68? I think I know, but I'm not sure. But I do know they're both even, so let's just divide both by 2 again. 28, 34. Oh my gosh, they're even again. 14, 17. All right. So it turns out 8 was a common factor. Greatest common factor. But that's just a quick way how to write a ratio. Now, number 3, kind of a formatting there, but we're just going to roll with it. Not very much room to write. We're just going to write over here. If 2 inches represents 50 miles on a scale drawing, how long would a line segment be that represents 20 miles? So remember, you can write like 2 to 50. Sometimes you can write ratios like this. All right, I call that the clock method. All right. However, the fraction method is just greater, or better, I mean. So for every 2 miles, 2 inches represents 50 miles on this map. All right. Now, how long would a x, we don't know what x is, how long would a line segment be that represents 20 miles? All right. So if 2 represents 20, how long would x represent 20? All right. So cross multiplication, huge concept. I'm going to say that a number of times. All right. We're going to get 50x equals 40. Divide both sides by 50. And x equals 40 over 50 and 4/5. All right, that's it. So you draw a segment 4/5 long, 4/5 an inch, or 0.8 inches long. That represents 20 on the map. All right, so some just cross multiplication review. Now we're going to practice more ratios and stuff like that. So below are ratios of a human. All right, this is a human being. I'll make it Mr. DeShetler. Here he is smiling, and he's got his nice hairdo. And here he is with his Apple Pencil. He loves his Apple Pencil. All right. So, what are the ratios of height to width of Mr. DeShetler? All right. Well, we're going to use K for scale factor, but it's height to width. So it's 170 over 40. And usually I like fractions, but for the sake of this one, let's go with a decimal. So I'm just going to plug this into a calculator and get the number 4.25. All right. Now we got a Lego minifigure. We'll make this Lego minifigure Mr. Vote. If you guys don't know Mr. Vote, he has a big mustache, almost kind of looks like the Pringle guy, and that's his regular mouth down there. All right, so that's Mr. Vote. The scale factor for him of height to width is 4 over 1.6. All right, and again, let's just plug this into a calculator, and what do we get? Ooh, we get 2.5. All right, and here's the dimension of a Lego dude. All right, this Lego dude, let's make Miss Linker. She helps us out first period sometimes. She has brown hair, black soulless eyes, beady eyes, and a long nose. That's Miss Linker. All right. Now the scale factor for Miss Linker, height over width, is 10.2 over 2.4, which OMG, 4.25. So which two figures are the most similar? Well, it was DeShetler and Linker. They're the same height and the same width. All right, they have the same proportions. All right, so it was the Human and Lego Dude. All right, they had same proportions. All right, they were the most similar. All right. And everyone loves to play with Legos, especially Star Wars Legos. And Lego movies are good movies. But nonetheless, here we got some more. We got some in-depth explanation of stuff. So two figures are said to be similar if they are the same shape. All right, so when two things are the same shape in more mathematical language, two figures are similar if their corresponding angles are congruent. So that's a huge thing. Angles are congruent. Ratios of lengths and corresponding sides are equal. So ratios equal, angles congruent. All right. So what does that mean? That's what we're really going to dive into moving forward. And in fact, not to make this video too long, we'll knock out the rest of this notes